Welcome back to another episode of How to Geometry. In this video, I'm going to show you how to utilize law of sines. Law of sines is a good tool to find the missing pieces in a triangle, in any triangle, not just a right triangle, specifically non-right triangles, right? Because if it's a right triangle, we have other trig techniques where we can use SOHCAHTOA, for instance, to help us find the missing elements. In this video, we are utilizing the law of sines, right? This is non-right triangles. So if you haven't done so already, please subscribe, like, comment down in the section below. Let me know what you think, and let's get it. Okay, law of sines. So here's the deal. When we have a right triangle, the shortcut, I guess you could say it's a shortcut, is SOHCAHTOA, right? If I have a right triangle specifically, SOHCAHTOA, the acronym that we use to help us remember the trig ratios, right? Sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right? This works beautifully in a right triangle scenario. Okay, in a non-right triangle scenario, SOHCAHTOA does not do anything for us, right? So any triangle that is not a right triangle, you have to do something else. And depending on what information is given, then you'll have one of two laws that you could follow or that it'll fall under, right? So again, if it's a right triangle specifically, you give me an angle and a side and everything is lovely. Like we can figure out all the missing pieces, all the missing sides, all the missing angles, if I know a side and an angle in a right triangle because of SOHCAHTOA. Okay, with that being said, here we don't have a right triangle. We just have an arbitrary, random triangle. And what the law of sines says is that there's a relationship between the sides and the angles in a non-right triangle. And specifically, a relationship between the angle and the side opposite of it. Right, there's a very particular relationship between the sine of A and the length A. In fact, the relationship is as follows. So we can take the sine of A and put it over the side length, little a. Or vice versa, right? You could put little a on top and sine A on bottom. It truly doesn't matter. But what law of sines says is that the relationship between all three angles and all three sides is exactly this. So it's going to be equal, like they're all going to be equal. So the sine of A, big A, over little a is going to be equal to the sine of big B over little b, as well as sine of C, big C, over little c, right? Or we could say, right, you could actually take the reciprocal of these and it'll still be true. So either one of these will work. So little a over sine A is equal to little b over sine B, which is equal to little c over sine big C. Okay, this is basically the law of sines, right? That there's a relationship between the angle, the sine of the angle, and the side across from it. And since there's three angles and three sides, they're all equal to each other, right? The relationship between the angle and sides, right? Because there's three relationships that's happening: little a, big A, little c, big C, little b, big B, right? The relationship between them is that they're all equal. Okay, so now I could go through and show you how we derive the formula, but I think it's more important that we know how to use this formula and apply it as opposed to where it came from. I can post another video showing how to derive it, but if you know where it comes from, but you don't know how to use it, then I think at that point it's pointless, right? So knowing how to use it is far more important than knowing where it came from, in my opinion, as far as practicality use is concerned. So we want to be able to apply this to a problem. A couple of notes is that when you're given your triangle, right, the process is going to be you take the given information and you start plugging the information in to the appropriate variable. So let's see an example. Okay, here's an example of a random triangle, and we're given two angles and a side. So it is worth noting that the law of sines works specifically when we know angle side. Like when you recognize that you have an angle side scenario, which this is one that we're in right now, right? We have two angles, so angle, and we have a side that is not in between the two angles, right? This side is outside of the two angles, like it's away, like it's not connecting the two angles. It's away from it basically. Or you could say side, angle. So any one of these two scenarios, law of sines will work. In fact, angle, side, angle will also work. So these three relationships, if you can recognize that that's the scenario that you're in, then law of sines will work. So let's write down what law of sines is. Okay, sine of big A over little a, sine of big B over little b, and sine of big C over little c. All right, in this particular scenario, there are no A, B's, or C's, like nothing is labeled. So we can label the triangle any way we want. I'm going to do it like this. So A, B, and C. Now it's very important that the side that is across from whatever angle has the lowercase letter of that angle. So for instance, since A is 79, across from it needs to be little a. Across from big B needs to be little b. And then across from C needs to be little c. Okay. If ever we know two angles in a triangle, we can always find the third angle, right? Because the fact that a triangle has 180 degrees total when you add up all three, and we know two, we can always find the third. So 180 minus 79 minus 52 would give us 49. So C is actually 49 degrees. 49. Okay. And now, given all this information, let's plug in to the formula and then see what we have. So if we do sine of A being 79, and it's over little a, right? Because we don't know what little a is at the moment. Sine of big B is 52, over little b, which is 28. And then sine C being 49 degrees, and little c across from it, we don't know. Okay, so now there's two scenarios, right? There's two scenarios. We want to either find A, little a, or we want to find little c. It all depends on which one you want to find. So you wouldn't find both of them at the same time. You had to find them individually. And what I mean by that is that notice how in the center we have a complete ratio, right? Both variables are there. So this is the only way that you'll be able to solve this is by having a complete ratio, right? Because if one of these three ratios were not complete, there's no way that you'll be able to find any missing element. So the way it's going to work, we're going to take either the two on the left or the two on the right. We're going to have to solve both of them, obviously, but we're going to solve them one at a time, meaning either the red box first or the blue box first. It truly doesn't matter which one is first. So I'm just going to solve for A first. So if I solve for A first, we want to solve just these two ratios, and we're going to disregard the sine 49C ratio. So off to the side, I'm going to say sine 79 over little a is equal to sine 52 over 28. All right, now we are basically, it's a proportion that's set up, and we want to solve for the single variable. Right? We only have one variable, little a. Now, because it's in the denominator, there's a couple different techniques you could use. The butterfly method I've heard. Personally, I like to bring up, cross multiply the denominators. So this is going to be 28 sine 79 is equal to little a times sine 52. Okay, we want to isolate a and get a by itself. So right now it's a times sine 52. So I want to undo multiplication by dividing sine 52. Right, we're dividing by it. Now I can do anything I want to this equation so long as I do it to both sides. So if I divided the right side by sine 52, I need to divide the left side by sine 52. On the right hand side, the signs are going to cancel, and we're left with a is equal to 28 sine 79 over sine 52. Now this is definitely calculator work. All right, if we round it to the nearest, or if we truncate it, right, we could truncate it to 3 decimal places. We're going to get little a is approximately 34.879. Right, truncate it to 3 decimal places, meaning we don't round. We just chop it off at 3 decimal places. Okay, that's little a. For little c, it's going to be very similar. Very similar. Except now we're using the right-hand side. So off to the side, I'm going to use sine 52 over 28 is equal to sine 70, or actually sine 49 over little c, over little c. Okay, again, all the variables are filled in except for little c, so we need to isolate little c. My technique, I like to bring up the denominators across. So this is going to be little c times sine 52 is equal to 28 sine 49. Now, isolating c in the same manner we did earlier, we have to divide both sides by sine 52. So we're going to get c is equal, right? C is equal to 28 sine 49 over sine 52. Go to the calculator. We get c is approximately 26.816. Now, you can do this method with any triangle that has these given elements, right? Angle, angle, side, side angle, angle, and angle, side, angle. Once you take the information and you start plugging the information into the formula that law of sine states, right? It's important that you recognize that you always must have one completed ratio. Okay, I do think it's worth noting that you could be given information, and when you plug in the values into the law of sines ratios, that you could very well much be in a situation as the one that you see here. So here, you know, two sides and an angle. However, one of the variables is an angle that we don't know. So when you're looking for an angle, inverse trig is the only tool that we have in our toolbox that finds the measurement of angles, that precisely finds the measurement of angles, right? Inverse trig. It's the only way. Now, when you set up your equations and you start to say, okay, I need to solve this for the missing variable. Well, big C is the missing variable. I'm going to bring up just the 20. In other words, I'm multiplying both sides by 20. So I'm kind of isolating the C. I'm getting C by itself. So this is going to be sine C is equal to 20 sine 82 over 29. Okay. To get to the C, right, I need to figure out what C is. So the way I'm going to isolate C is we have to take the inverse sine of both sides. That's the only way to undo the sign on the left-hand side. So in a calculator, you would just type it in. However, on paper, the way it looks, it's kind of weird. But we have to take the inverse sine of both sides, right? Because I can do anything I want to an equation as long as I do it to both sides. So there, I've taken the inverse sine of both sides. On the left-hand side, the sine and inverse sine, they cancel each other out in the same manner that a square and a square root cancels each other out, right? Once they touch, that's it, like they cancel. And so we're left with the angle, big C, which is equal to inverse sine of 20 sine 82 over 29. And now, 1000%, this is calculator work, right? There's no reason why anyone should know this. Okay, this comes out to approximately 43 degrees. 43 degrees. So recapping, when you fill in your information and you're missing an angle and you need to find an angle, inverse trig is the way. And you set up your proportions, and when you start solving to isolate the angle, inverse trig is the only way to undo whatever trig function you're using, right? Like, so had this been, well, no, I'll take that back. You have to use inverse sine to undo the sine. Okay, let's see some examples. At the top, I'm going to write the law of sines down. Okay, keeping it handy, right? Just remember big A over little a, big B over little b, and big C over little c. Okay, number one. We're going to use the law of sines to figure out the lengths. So nothing is labeled, so I'm just going to make up my own labels. So this is going to be A. Across from it, this is little a. We can call this big B. Across from it, little b. And now, do I need to mark big C and little c? No, I don't necessarily have to because they're both blank. So since I'm looking for M, I mean, just so you can see, obviously this is big C and this is little c, right? Because they're the last one. So I'm going to set up my proportions. So sine of A, which is 40, over little m. And then sine of B, big B, which is 51, over little b, which in this case is 17. So here's my law of sines setup. Notice sine 51 over 17 is complete, right? The only thing that's missing is one variable. So if somehow you set this up and you have two variables, then you've done something wrong. Or it's not going to work and we have to use law of cosines probably. All right. So bringing up the variable and bringing up the 17, we get 17 sine 40 is equal to m sine 51. Okay, isolating m, we're going to divide both sides by sine 51. 51's cancel on the right. So little m is equal to whatever 17 sine 40 divided by sine 51 is. So it's definitely calculator work. We'll take it to the nearest degree. Unless it says, let's see, hold on. Use a calculator. Truncate your answers to 3 decimal places. So we want 3 decimal places. Truncated, meaning not round. Do not round. So 14.060. That would be little m. Okay. Number 2. We're looking for P. So I want to put sine of the angle, right? Sine of the angle over the side across from it. So little p. And this is equal to sine of 22 over the side opposite. In this case, 12. Now, if you couldn't see this, we can call this big A, little a, big B, little b, and then plug it into the formula and it would work. Or it would come out to what we have right now. Okay, trying to isolate P. It's in the bottom. So I'm going to bring up each of the denominators. So this is going to be 12 sine 32 is equal to P sine 72. All right, we want to isolate P. We're going to divide both sides by sine 72. Right hand side, it cancels. So P is going to equal 12 sine 32 over sine 72. This is going to be 6.686. Okay. I guess it was worth noting that in both of these, right, this was angle side. And the middle one, again, was angle side, right? The side was not included in between the two. And again, another angle side. So this is definitely law of sines. Okay. So again, I'm taking the angle, sine of the angle, over the side across from it. So sine of 76 over 21. This is going to be equal to, okay, we want to solve for Q. Right, Q is in the bottom, but I need the angle across from it. So here, they didn't give us the angle explicitly, but we can find it. 180 minus these other two angles. So minus 67, minus 76. This is 37. So sine 37 over Q. Okay. Bringing up the denominators, like cross multiply basically. Q sine 76 is equal to 21 sine 37. Solving for Q, we got to divide both sides by sine 76 so we can isolate Q. So Q is equal to 21 sine 37 over sine 76. Put this in the calculator. This is approximately 13.025. Okay. So 4, 5, and 6, the proportions are already set up for us, except we're missing the angle. We're looking for the angle. So anytime you're looking for an angle, inverse trig is what should be going off in your mind, right? A red flag. We need inverse trig. So number 4, I'm going to multiply both sides by 16. That's the only way to get rid of the 16 that's in the denominator, because I want to isolate C. Then, because it's sine, and this is law of sines, we're going to take the inverse sine of both sides. So this is going to be C, right? Because this sine and this sine cancels essentially, and we're left with C. Be like, we've unlocked it. And this is sine inverse of sine 81 over 29 times 16. So we could actually put the 16 in front. And now this is calculator work. All right, we get approximately 33.019. Okay, number 5. Again, P is in the numerator, and it's inside the sine. It's an angle, and we need to get to it. So we have to move the 26 to the other side, basically by multiplying both sides by 26. Then, to get to the P, right, we need to take the inverse sine of both sides. When I do that, that sine's going to go away. That's what's happening. So P all by itself is equal to inverse sine 26 sine 32 divided by 48. So going to the calculator, sine of 26 sine 32 over 48. We get 16.680. Okay. All right, another one. Again, we're solving for capital K. So I got to multiply both sides by 47. That's going to go away. Then I got to take the inverse sine of both sides. Essentially, that's going to go away. So K by itself is equal to this thing on the left. So 47 sine 78 all over 105. We get 25 0.965. All right, number 7. Two angles of a triangle measure 56 and 77. So let's draw a picture. I draw the same triangle every time, regardless of the scenario. So two angles are going to be 56, 77. So angle, angle. The side opposite of 56 is 29. What is the measure of the shortest side? Remember, the shortest side is going to be across from the smallest angle. So here they gave us two angles. Let's figure out what this third angle is going to be. So 180 minus 56 minus 77 is actually 47. So 47 degrees is the smallest angle, which is going to be across from the shortest side. So I'm going to take sine 56 over 29, right? Because that's, in a sense, this is, you could think of this as like big A, little a. And then this is equal to sine 47 over, we can call this little b, little c. It truly doesn't matter. We go little b. Little b, that'll make this big B. Okay. Bringing up the variable, bringing up to 29. B is equal to sine 47. No, take that back. Sine 56. Oh, hold on. What's going on here? B is equal. So B sine 56 is equal to 29 sine 47. So to get rid of the sine 56, because I want to isolate B, we have to divide both sides by sine 56. We go to our calculator. Okay, this is going to be little b is going to equal 25.582. Okay, all right. A large helium balloon is tethered to the ground by two taut lines. So here's my weather balloon and two taut lines. One line is 100 feet long and makes an 80-degree angle with the ground. So if this is the ground, this is going to be 80. The second line makes a 40-degree angle with the ground. That's 40. How long is the second line? Okay. Remember, law of sine says the angle is proportionate to, or the angle, the ratio of the angle and side across from it, sine of the angle and the side across from it is equal to sine of the other angle, and then the side across from it. So sine of 40 over 100 is equal to sine 80 over x. All right, we're bringing up the x's. So we're going to get x is equal to, I did it again. Sine 40 is equal to 100 sine 80. All right, last step. We're going to divide both sides by sine 40. Cancels on the left. So x is equal to 100 sine 80 divided by sine 40. 153.208. And this will be feet. Right, feet. Okay, I hope this video was helpful. Stay tuned for the next episode where I go over the law of cosine.